Hey, I'm Celine.
And I'm William.
And we are on the Big Sky Robotics team at MSU. And just for a quick recap of what we did yesterday, we got to view the game reveal, and we immediately started brainstorming ideas for the different mechanisms that we would need for our robot. And we got to start CADing some prototypes, and we selected a few that we really liked and moved forward with those.
Yeah. So today we initially finalized our prototypes, got wonderful designs like this from Ethan and Jono, and then we moved on to basically gathering parts and initial fabrication. And right about now, we are just about kind of almost done with initializing the elevator and whatnot, and we're just starting to move on to the manipulator.
My name is Jono. I'm one of the design leads for Big Sky Robotics this year. I'm going to give a brief overview of our robot architecture and how it works. So here we've got an intake that flops down to ground level, and it's able to intake both algae from the front and then lift up and spit it out into the processor. And then it's also able to grab coral, and it's able to do this by spinning these two sets of wheels at different speeds, and we can get it into these wheels and then rotate this vertical and hand it off up to our end effector, which is on a cascade rigged arm with a elbow pivot point and a wrist pivot point, so 3 degrees of freedom. And from there we're able to move the coral all the way from levels 1 to level 4 to score it. We also plan to use the elevator to climb at the end of the match based off of the first stage.
All right. My name's Ethan. I'm a design lead on Big Sky Robotics, and my main responsibility this year was the intake, the prototyping, and the final design that came along with that, making sure it actually met all our performance requirements. So starting out here with kind of what the final design that we ended up going with, we went with an intake that is dual purpose, that can do both algae and coral, using 2 sets of entrapment stars and then some 3-inch compliant wheels in the back. We decided on this design because it kept everything to one fairly simple mechanism that can just essentially drop over the bumper and just kind of sit flush with the ground and pick up both game pieces that way. Super simple, super easy to execute the design of this and get it done fast. And we're pending a little bit more testing once we get this final revision on the robot. I have very high expectations for its performance. Diving a little bit more into some of the more nitty-gritty details. We have 2 independently driven sides of our intake, just on 9:1 Versaplanetaries and Neo 550s right here and here. The entire thing is belted for maximum weight savings. We have 18-tooth pulleys because there's not a lot of load going on here, so we can kind of just go with the smallest size for ease of packaging and minimum weight. Same on both sides there. For our coral intake, we actually spin at a slight speed differential to kind of vector it in a little bit like this, so that it kind of gets sucked in and is perpendicular to our bumper, as that's the configuration we need it in to score it. And for algae, the expectation is we're just going to be running both sides at the same speed and just taking it in that way. Getting a little bit more into what it's attached to here, we just went with a very, very simple pivot design coming off our chassis. We have a Neo on a 48-to-1 57 Sport gearbox and some big gears here for ease of packaging and strong gears so we don't have to worry about them breaking. And then the actual pivot itself is a live axle with the Versa hubs, and we're essentially just going to be bolting these into here and coming at it from the other side. So overall pretty simple. All these designs kind of need a little bit of a starting point. So this right here was our true, like, most developed prototype. There are quite a few things that are minor differences here between the final design and things that we just wanted to slightly tweak. There was this bar in the back here. This was our main problem, and why this one in the CAD actually has this big separation back here and nothing impeding that path of the coral, because it would always get jammed right here, and that's not something we really wanted on the final revision, so we eliminated that. We also found that at times it wasn't the most sticky when the coral was between these. When we shook it around, the coral would sometimes fall out. So we just added a second set of compliant wheels to this design, and they fit pretty nicely. We didn't have to do anything additional for that to work, so that was nice. This whole design weighs somewhere around on the order of like 6 pounds, not including the part that mounts to the chassis. A lot of effort was put into weight reducing this as much as possible, just to ensure that we minimize current draw on our motors and also try to stay afloat of that weight limit this year, which is 10 pounds lower than previous years. So yeah, just a very simple intake, but one that we really needed to make sure worked in our design with our 3 degree of freedom elevator and arm setup.
All right, so now kind of moving into how we're going to score the coral. So after we've intaked it and brought it up vertical here, we can look at this sketch of kind of the side view of our robot. Here we can see the starting configuration of our elevator, and then the total height once we're at the top, then the arm, as well as like the length of the arm, and then the length of the wrist, where the coral will be positioned. In this case right here, we're here for a level 4 coral on the reef, just barely above, a few inches to spare. And then we can also move that down for the level 3 coral and the level 2 coral, and then as well level 1. And then for that transition, the arm will rotate back down to grab it from the intake. So it's able to go a full plus minus 90 a degree of freedom. And then we can take a closer look at the end effector and how we're actually going to hold the coral and score it. So we've got these 2 rollers here. And this is the same, very, very similar design to what we have right here. That's worked very well. This has very, very firm grip on the coral, and it will grab onto it from the other intake and then rip it right out. And then it is on a wrist here. This wrist uses some 3D printed herringbone gears and a remotely located motor up on the arm to power it, to keep our weight as far away from the end as we can. So that gets us a range of motion of about 270 degrees on this, so we can go all the way back to all the way under. And then kind of moving all the way up our arm to our elbow gearbox. This we actually have 2 Neos and some 57 sport gearboxes from Andy Mark. They're both 100-to-1s, and then those go to another gearing stage to the spline XL shaft, goes straight through. So it's a live axle. We're using the West Coast Products blocks for the spline XL right there. We've got a through-bore encoder on that to get our absolute position. We have another one down on the wrist. So we have a 3 degree of freedom system here. So we're really trying to get help our software team as much as possible. But that kind of is all on the carriage. And then the climbing system is not yet modeled, but we're going to add to the bottom of our carriage, not the carriage, but the first stage, some kind of hook that we will put into the bottom of that cage and pull down on it. So we'll have more torque because it won't be on the carriage with the first stage, but our mechanism remains on the carriage here.
So basically, in advance of the RiD, we went ahead and built our drivetrain at the start of the year, which has a water-jetted brain pan, which is very easy to add many different types of parts to. After the RiD, any actual parts, such as the elevator, that we actually want to put on there are very easy to implement, which gives us a lot more time when actually building the robot in the 3 days, because we don't have to worry about our drivetrain.
So, and to add on to the drivetrain, you guys saw how we designed our elevator, which is going to be our main strategy for this game. And how we went about manufacturing that was we cut all of the stock aluminum down to the sizes we needed according to the CAD. And then we went ahead and laid it all out in front of us to see how that would fit together when we connected them. And we realized that we needed to build some custom gussets to be able to connect them properly. And so we went ahead and bandsaw cut those along with some churro for our spacers. And yeah, it's coming along really nicely, and I think it's going to be really cool.